And that's through using technologies like the DLP technologies, the digital light processing technologies that are a part of the MEMS group. So the DLP are very small individual light mirrors. But what they are is these micro mirrors are actually controlled with a digital control signal. And they just tilt. They're very, very small, much smaller than a grain of salt. And they allow, when you drive them with a control signal, they will tilt one way or another. And through their ability to go with a different colored lamp, you can actually change the amount of image that is displayed through a projection lens. This is a very popular technology on high-definition television systems and projection systems. And of course, you can generate, high contrast, high definition, and high resolution color images with these technologies. DLP is also used on in skin cancer detection. That's another area that DLP is used. The vein viewer is another popular application for the DLP technology. And programmable light engines. So what they do with using the DLP technologies, they use a very wide spectrum of light source, like a xenon lamp, and then they split the image through, or they split the spectrum up, display it onto a DLP light engine, and then using that, they can actually indicate the different intensity and the spectrum content of the light that's used. This is something that's very repeatable. So once it's programmed and they actually segment out the spectrum that they want, they can reproduce this over and over again. So it's a very reproducible type of light source. Through wireless technologies, and there are many of them, you are able to move data wirelessly. So from a remote location there's a body area network down in the far left where a person could have a smart bandage attached to their forehead. They may have a cuff monitoring their pressure on their arm. And this is all transmitted down to or received by a smartphone or a PDA. And it may transmit the data once the person goes back to their home to their local area network. From there, it can be sent or transmitted back through the wide area network to a hospital environment or some monitoring situation that needs to take care of that. So there's Bluetooth Low Energy, ANT technologies, Zigbee, a number of wireless technologies that are used for this type of monitoring. And through some of this wireless technology, the aging independently, or the ability for people to stay in their own homes till they're much older, allows them to be able to have the wireless fobs that they wear, and through a care system, they could be monitored for their received signal strength to know that they're actually moving around. If they're not moving for a period of time, it could indicate that some call has to be made to that person to see why that they're not moving. There could be fall detection sensors built into their wireless fobs as well. Power is always important. As time moves along, more and more low power devices are obviously very, very critical for some of the advancements in medical. I'm going to rush through a little bit of this, but this is an example of some of the things that are being worked on and devices that are being developed today. The one interesting point there, the retinal implant, I was quite surprised, but we're actually doing some development with USC on a implantable retinal sensor, and this takes thousands and thousands of sensor nodes, and it's interesting developments that are being worked on. So the things that you can imagine, all of the smaller, the lower power devices are making this is all capable and possible. So there's this strong trend towards the healthcare market. Medical electronics is a strong market and continues to grow. We see that the smaller, the lower power devices that are being built today are going to make this a very interesting market for ourselves and other medical electronics manufacturers. So that was my presentation today. Thank you.